This topic is more examples for choosing an appropriate method for gathering data. It says Washington High wants to estimate the number of students who drive to school. Answer the following. Part A, which of the following surveys probably would best represent the entire student population? So first part says 50 students are randomly selected from 11th grade and 14 drive to school. I like that they're randomly selected, but it was only from 11th grade. The second one says 50 students are randomly selected from the math club. I don't think that the math club is representative of the entire school. And just like the 11th grade is not representative of the entire school. And the last one says that 50 students are randomly selected from the entire school. I think that is your best choice. Part B says there are 1,450 students at Washington High. Using your answer from Part A, estimate the number of students who drive to school. So from Part A, we know that 13 students drove to school out of the 50 that we randomly selected. So this is the ones who drive. This is our total. And now we're setting up a proportion. The total for our proportion is 1,450, and we don't know the number who drive. Rather than simplifying this, an easy way that I can do with this problem, because it's 50, is change that 50 to 100, and then we have a percent. So now we know that 26% of the kids in our survey drove to school. So we can now multiply 1,450 by 26%. And that would be 27, 6, 7, 8. So 0, 10, 9, and 2. And just add everything up. 17. And we have 2 digits after the decimal. So our estimate is 377 students in the entire population of the school drive themselves to school. Let's look at one more example. It says town officials want to estimate the number of households that own a dog. Part A, which of the following surveys probably would best represent the entire population of households? So again, when we're trying to survey a population, we want to do it randomly, and we want to make sure that we're getting all parts or all segments of the population, meaning not just people who own a house, not just people who have kids, not just people who have pets. We want to just randomly survey everyone. So the first choice is 20 households within a mile of a park are randomly selected. I like the randomly selected, but within a mile of a park, you might be more inclined to buy a house within a mile of park if you own pets. So that might make our survey question or our survey biased. And the second part says 20 households are randomly selected from the entire town. That sounds like we're getting the entire population of the town and we're randomly selecting them. And the last one says 20 households with a backyard. Same thing as the first one. You might be more inclined to buy a backyard if you have a house with a backyard if you own a dog, or you might be more inclined to get a dog if you have a house with a backyard. So I think the best survey question is the second one. Part B, there are 400 households in the town. Using your answer from Part A, estimate the number of households that own a dog. We're going to set up a proportion. In our survey, 7 owned a dog out of 20 total. So this was dog, this was total. And that's going to be equal to 400 total. And we don't know how many are going to be owning a dog. We have a couple of options. We could cross multiply to solve this proportion here. But I think I would change 7 over 20 to over 100 because then I would have a percent. So if I multiply by 5 over 5, I'll get 35. So 35% in my survey owned a dog. So now I'm going to multiply 400 times 0.35, which is 35% as a decimal. 4 times 3 is 12. 2 digits after the decimal point. So I'm estimating 140 households own a dog.